Hi everybody, it's Sunday and I realize that my videos are probably running a little bit long. I just really want to make sure that I'm explaining things to you that I can't do in person. So I'm going to try part 2 of chapter 9 and focus on the differences between the natural causes of climate change and the anthropogenic activities that are affecting our atmosphere and causing a rapid increase in temperatures on Earth. That is global warming. So our atmosphere is something that protects Earth. You watched the video that talked about if we lived on the moon or we lived on Mars, it would be freezing and boiling and life would not be very pleasant. And our atmosphere provides us with something called the natural greenhouse effect. So that natural greenhouse effect is a result of incoming radiation into the Earth. Some of it's reflected, but most of it comes in, 70% of it gets in, and that incoming radiation is absorbed by the Earth. It's absorbed by water, it's absorbed by land, it's absorbed by ice in some cases, and then it's re-radiated back into space, but it's not lost in space, it gets trapped by our atmosphere. That infrared heat gets trapped by our atmosphere. And our atmosphere is made up mostly of nitrogen, 78% nitrogen, 21% oxygen. We talked about that in chapter 3 and in chapter 10. Those are things you should be aware of, but it has some trace gases in it. It has carbon dioxide and methane and nitrous oxide and some argon, and it has water vapor in it as well. And these are called greenhouse gases. And they're called greenhouse gases because of the way they absorb heat. And it's talked about that here. How do greenhouse gases really work? I suggest you re-watch that video to understand it better. This is a natural effect on Earth, and our atmosphere is like a thermal blanket. It's keeping us warm and it's moderating our temperature by absorbing some of the heat coming off of the Earth. And these gases are very important in doing that. Well, what are human beings doing to change that? Human influences on the atmosphere are changing the greenhouse effect. Temperature of the atmosphere can be affected by solar radiation. We can't affect that, right? Earth's orbit, Milankovitch cycles, we can't affect that as human beings, or volcanic activity, or the El Nino Southern Oscillation, or plate tectonics. Those are all natural causes of climate change. We can't affect those, but we can affect what we put into the atmosphere, and that's what we're doing. We are changing the amount of carbon dioxide through deforestation and fossil fuel burning. We are changing the amount of methane, putting more in through industrial and agricultural processes. We are changing nitrous oxide through industrial and agricultural processes. And these three gases absorb a disproportionate amount of light energy and trap, and they trap it as heat. So definitely rewatch that video. I think that will make a big difference. So as we increase these greenhouse gases in the atmosphere, what happens is we are turning up the thermostat on that thermal blanket. And we are doing it at a rate that we've never seen it before, that we can look at either through human history and records that we have been able to keep in our lifetimes, or going back through ice cores and marine sediment and looking at the data that's called proxy data that is being kept in those sediments for us. And we can actually see that. So definitely understand those concepts of how we can find out what the levels of gas were 800,000 years ago, because human beings weren't measuring it 800,000 years ago, but the ice was trapping it in bubbles for us. So we can see that humans have impacted the atmosphere through deforestation, which is cutting down trees, right, and removing the ability of trees to absorb CO2 and put oxygen into the atmosphere. And we are doing it through fossil fuels. Fossil fuels are long-term carbon storage. It takes millions of years to produce gasoline, petroleum, natural gas, and coal. Those are fossil fuels. And when we take those out of the ground and burn them, we are taking long-term carbon carbon storage that's been sequestered for millions of years, and we're putting it into the atmosphere in a really short period of time. Much faster period of time than it can be replaced. I also want to make just a comment about synthetic greenhouse gases. When we decided to replace chlorofluorocarbons, which was harming the ozone, and the ozone is something that protects us from the sun. The ozone layer is not part of rapidly warming climate on Earth. It is a separate issue, and sometimes people get confused on that. When we were able to determine that the ozone hole was being damaged, that meant that more UV radiation was coming into the Earth, and that damages human tissue. More so than the UV radiation that could be filtered out through the ozone layer. So by taking chlorofluorocarbons and replacing them with something called hydrofluorocarbons, we helped the ozone layer. What we didn't help was greenhouse gases, because hydrofluorocarbons are a greenhouse gas. And that is one of the other things we're doing to add to the environment and the atmosphere. That is increasing the ability of our atmosphere to absorb heat. We can measure carbon dioxide in the atmosphere, and it's been done since 1960 very successfully on Mauna Loa, which is a mountain in Hawaii. We've measured methane and nitrous oxide. You need to look at this information in your PowerPoint as well as your e-text. And you need to know where these greenhouse gases come from. They come from burning fossil fuels when we generate electricity, when we make concrete, when we have livestock and we use fertilizers. And there's a difference between countries, if you're industrial or you're in the developing stage, as to how much greenhouse gas you use. And when you look at agriculture and electricity and heat production, that's 50% of where greenhouse gases come from. Transportation is here, and industry is here. So how we grow our food and how much meat we consume and how we generate our electricity and produce the heat that we need, these two things can impact greenhouse gases in a way much more than the kind of car that you drive. That's still important, but this is what you want to focus on, that you understand where greenhouse gases come from, that you understand that not everybody in the world has the same per capita CO2 emission. So I wanted to make sure I focused on a couple of those things in a little more detail. Please go through the PowerPoints. Please look at your textbook. Please go through the dynamic study modules as well as the clicker PowerPoints, and then you will do great on the exam.